welcome to PhyzQuest. So this is the solution video for CSIR NET December 2019 Part C, question number 26. The question is, an alternating current I is equal to I naught cos omega t flows through a circular wire loop of radius capital R lying in the xy plane and centered at the origin. The electric field E and the magnetic field B are measured at a point R, where R, the distance R is much higher than C by omega, which is much higher than the radius capital R. So there are 4 statements are given and we need to choose the correct statement. So let's get started. So this question comes from the section Electromagnetism, and the concept involved here is magnetic dipole radiation. So here we are given there is an alternating current I equal to I naught cos omega t, which is flowing through a circular loop of radius capital R, which is in the xy plane. So now whatever 4 options are given, they all points towards the time average values of electric and magnetic field. So here we need to calculate the time average values of electric and magnetic field, and the condition here is that both are measured at a distance R, which is much higher than C by omega, which is again much higher than the radius capital R. So this is basically called the radiation zone. As discussed in the previous question, where we discussed about the electric dipole radiation, so magnetic dipoles also emit radiation. Now, so an AC current here flowing through a loop, it acts as a magnetic dipole. So first of all, if you calculate the magnetic moment here, this will be equal to pi r square I t z cap. Now, in order to calculate the electric and magnetic field, we must know the scalar and the vector potential. Now, since there is no net charge on the loop, therefore the scalar potential will be equal to 0. Now, when we calculate the vector potential with the condition given that the distance r is much higher than C by omega, which is again much higher than capital R, that is basically the radiation zone. If you calculate the expression of vector potential, expression of A will be equal to minus mu 0 m0 omega divided by 4 pi c sin theta divided by r sin omega t minus r by c phi cap. Why phi cap? Because these are expressed in case of spherical polar coordinates. So phi cap is your azimuthal direction. Now here I am not deriving the whole expression of electric and magnetic field, because you can consult any textbook of electromagnetic theory. The expression, because the deriving them will be very lengthy, so we just write the expression and use them to analyze our statements given in the option. So let's do that. So electric field E is minus del A by del T, which is equal to mu 0 m0 omega square divided by 4 pi c sin theta by r cos omega t minus r by c phi cap. Similarly, magnetic field, which is del cross A, this is equal to minus mu 0 m0 omega square divided by 4 pi c square sin theta by r cos omega t minus r by c theta cap. So in this problem, see here actually we have to remember the expression. So now let's discuss the option here. So these are the 4 statements which are given. So first of all, option A says the time average value of electric field is proportional to 1 by r square. But actually if you look at the expression, this is proportional to 1 by r. So this is not correct. Similarly, option B says the time average value of electric field is proportional to omega square, which we can see that it seems correct because we have a term omega square here. So electric field, time average electric field is proportional to omega square. Now let's check the other 2 options. So option C is says time average value of magnetic field is as a function of polar angle theta has a minimum at theta equal to pi by 2. So now here, as you can see here, it is a function of sine theta. Now sine theta when has a maximum value at theta equal to pi by 2. So therefore this expression at theta equal to pi by 2 will give a maximum expression. It will definitely not give a minimum value. So this option is also not correct. And last option is this magnetic field is along the azimuthal direction. But we can see that in the expression of B, in which the direction is theta cap, which is actually the polar direction. Azimuthal direction is your phi cap. So This option is also not correct. So out of all the four options, the correct option is option B.